Hello all. In this session, we are going to discuss about the data types that we often use or come across in data science. These are somewhat different from the data types that you already used in C or C++. We only are going to discuss about the data types that we use in data science. Because it is an essence of discussing about the data types. In data science, the essence is to collect the data initially. We need to collect the data, pre-process data, and we are going to transform the data from something to something else. This is what a total essence of the data science, during which we should be able to deal with a lot of data during the collection. So what kind of a data that we are going to deal with? Let us understand. The first one is the numerical data. What is the numerical data? Numerical data will again be classified into two categories. The first one is the discrete data, second one is continuous data. What is discrete data? It's a countable value. If there is a domain, such as students, number of students in a class, or number of clicks on a website. If it is a domain, particular domain, it will be ranging from 1 to any unrestricted level, right? This is going to be represented as a discrete data. This is just discrete data is just nothing but a countable value. Typically, it will be represented with an integer, 1 and so on, or 0 from so on. And the second one is a continuous data. Sometimes we often collect data which is called a continuous data, which can be classified into continuous data. What is this continuous data? This data at a specific point will be at one value. At another specific point, it will transform to something else. Rather, it will be varied to something else. For an example, temperature. When you wake up in the morning, temperature will be something, maybe 28 degrees. Right at the 10th hour, it will be 32 degrees or 33 degrees. So this is variable. This continuous data meaning it's a variable data. For an example, we have a height. Height is going to change over a period of time. And weight also changes time to time. And similarly, temperature. This continuous data can be defined as a measurable values that can take any value within a range. But there is an upper bound for the continuous data. Whenever you take a age will be having an upper bound that is 100. Often that doesn't cross 100. Weight will be constrained in between 0 to 200. Max is 200 and the min is 1 kg and so on. So there is a measurable quantity which has a lower bound and an upper bound, which comes under the continuous data. Next thing is, of course, the use in data science is techniques like normalization and scaling apply to handle the range of continuous data. Now, whenever we are dealing with the data, whenever we collected the data, of course, this continuous data or numerical data we are going to collect too often. It is widely spread across the data science. The data, the numerical data, often we collect. Sometimes we directly collect or we transform another data to the numerical data. For an instance, I just got an image. Image cannot be processed the way it is. Image has to be divided into pixel. Each pixel is a square value, is a square in which we are going to put a numeric value, which is corresponding to how that pixel appears. For an example, 0 being the darkest side, 1 is being the brightest side. Every pixel has to be converted into its respective numerical value. This is the use. Every data will get converted to the numerical data. We are going to use some normalization techniques. Now, what is normalization? Like, for an example, the values if are in between 0 to 255, these are varied across 0 to 255, meaning these are distributed from 0 to 255, which is very difficult for the model to perform. There is some technique called normalization, which we are going to understand very in detail from the next topic, next chapter onwards. But in a nutshell, normalization meaning, if there is in every pixel has to be simple. One example, I'm going to take an image. In image, we have several pixels, 28 by 28, meaning there are 28 rows, 28 columns. Every position we have a pixel. Every pixel value will be from 0 to 255. Since the values are distributed from 0 to 255, it is difficult for the model to perform. Model to do the operations convolving operations or machine learning algorithms to be implemented with. So what we do is we generalize or normalize all the values to a certain range. All these 0 to 255 values will be normalized from 0 to 1 only, most of the cases. This is called normalization. Some normalization and scaling are applied to handle the range of continuous data. But why do we use numerical data in data science? Statistical analysis. We're going to analyze, statistically a particular model, and regression model. There are two models such as classification and regression. We're going to use this numerical data in regression very often, and machine learning algorithms. As I already told you, everything must be converted to the numerical value. Either it could be continuous or discrete. Okay, so next thing is the categorical data. What is the categorical data? Categorical data, of course, it is non-numerical. For example, the color combination. You have a color combination RGB, red, green, blue, or a week, Monday to Sunday, right, from Monday to Sunday. This is what a category of the data. When we collect this category of the data, we should be able to represent this categorical data in some way or the other. I'll tell you more. Categorical data represents a qualitative characteristic that describes item but don't hold any inherent numeric meaning. Those are not numeric. Unless we convert them into numeric, those are stand-alone data, such as red, green, blue. Red doesn't have any numerical significance, being a color. Green, similarly, blue. Even Monday to Sunday, those just are the discrete independent values. But they are related to each other, which is going to form a category. Okay, now nominal data, categories with, again this is categories into two things. One is nominal data, one is ordinal data. What is nominal data? Categories with no specific orders. Categories with no specific order. There is no ordering at all here. Okay, so red, green, blue. There is no specific order. Gender, male or female. There is no specific order here. Okay, and ordinal data, categories with a meaningful order, but intervals between them are not consistent. When it comes to the ordinal data, this will have a meaningful order. It will have one order or the another. For an example, there is an education level. Education level actually starts from 10th class. There is an order 10th class and from so on. And similarly, rating scales, poor, good, excellent. Here, there is a specific order here, right? Yeah. So, this is what a categorical data. Categorical data doesn't have any numerical significance unless we convert this into this categorical data we often deal in the data science. Okay, this is used in decision trees and k-nearest neighbors algorithms, and the logistic regression use categorical data for the classification task. This categorical data will be used for the classification task, and we have to encode it. Encoding techniques we're going to deal later, but I'll tell you what exactly is the encoding in a nutshell. We need to often encode this categorical data by using something called a one-hot encoding. I'll tell you by using a simple example. That is, let us say RGB. Okay. Every time when I have to mention some color combination, RGB should be mentioned. But how it should get encoded? Here, RGB, three distinct values. To specify one color here, I need to take the reference of even two other colors. If I have to specify red, red will be given as 100, meaning red will be hot here. And again, I need to specify green. Rather than directly specifying green, I would say 010. That means 1 is attributed to G here. Similarly, 001 stands for blue. Although we are picking up a simple, only one color to address, we also need to take the other colors during the encoding. 001 meaning blue, 100 meaning red, and 010 is for green. This is how one-hot encoding works. Okay. Next thing is the text data. This text data refers to the natural language data. What is natural language data? Sometimes you want to communicate with the other person by using an email or a message. Here, you're going to communicate with the other guy using the text. So whenever we are analyzing, whenever we are collecting the text data, there has to be some framework. So we will see how the text data is going to be dealt with. Now simply, what exactly is the text data? Text data example is the emails. For instance, I want to develop a model which is going to figure out the spammed email. That model will have to analyze a wide range of the emails in which this model will be trained in such a way that it is going to pick out a spammed mail. For that, it is going to analyze the keywords. In spam email, there will be some keywords will frequently be repeated. It is going to identify those keywords. Emails with those keywords will be categorized as the spammed mails. So now, how exactly the text data is going to be dealt with? In a nutshell, text data refers to the natural language data. Natural language is the language that we communicate orally or verbally with each other. Text data refers to the language that we use and such as words, statements, sentences or entire documents. It is typically high dimensional and requires specialized techniques for the extraction and analysis. There is a problem with the text data. For example, you take an email. Email is a collection of several data elements. There will be sentences, statements, and tokens, or the tables, or the values. Here, separating them, segregating them, classifying them, or categorizing them is the biggest challenge as compared to any other data items we discussed so far. So, to process the text data, we use something called natural language processing techniques. These natural language processing techniques, such as tokenization, stemming, lemmatization, and vectorization, will be able to segregate the data into the respective categories, because whenever we are dealing with the text data, it's a collection of several data tokens together, maybe statements or tables or the values, discrete values or the whatever. It is a collection, it's a complete pure raw form of the data. So to segregate, it's the biggest challenge. But for that, we do have some tools in the natural language processing, such as tokenization, stemming, lemmatization, and so on. But always text data imposes a lot of problem. Dealing with the other data is not as difficult as dealing with the text data. Okay. And the next thing is the image data. We often deal in our projects, in our CNN or ANN. Often we deal with the images or sounds. But what exactly is image data? Image data is a visualization data in the form of pixels. Eventually, image data will also be converted to a numerical data. Image data background is a numerical data, a 3x3 or a 28 by 28 or 455 450 by array, in which each pixel is going to represent a range of values from 0 to 255. If it is RGB, each pixel is going to show 3 values. One is for R, one is for G, one is for blue. Anyhow, since we already discussed, examples for the image data is photographs, medical images, and satellite images. There are wide variety of the projects actually based on the image data. Okay, using the data science for the computer vision techniques, convolution neural networks, we are going to deal a lot with the image data, as I already talked about.